Hello, good afternoon all. Welcome to SOA Weekly Academic Lecture. This is lecture number 4. Good afternoon, sir.
Good afternoon, ma'am. And good afternoon to all others.
Good afternoon, sir.
Hope I am audible clearly.
Yes, you are clear.
Okay.
Subraganda, are you in college?
Yes, ma'am. Saturday actually is not a holiday. It says
Half day also. But thank God that is due to the shutdown in Odisha. Saturday, Sunday weekend. We are getting it as a fully holiday.
holiday.
Yeah, fully holiday.
Madam, on campus classes have started there.
No.
Okay.
That will start next week, I think.
Hmm. But it will be a little like initially we had a discomfort in online classes. So now when the physical classes start, it will be another problem. Like most of us probably have lost the habit of speaking to the large audience
Yeah.
as you used to do in the classrooms. So we have entered into the comfort zone of this online mode. So physical
Ego. Yeah.
classes
Yeah.
initially will be
2 years
little hectic.
now, we are getting experience 2 years. We are getting
Yes. Yes. Now here at BITS also we are planning to have students in campus, but the classes will go online.
Sarada sir, are you here?
Yes, madam. Good afternoon.
Good afternoon, sir. Sir, will you start?
Uh, yeah, I guess we should wait till 4:05. Let's wait for two, three
Okay.
minutes. I guess students are joining.
Yeah.
And ma'am, please start the recording once
Yeah.
the lecture starts. Yeah. Thank you.
Our expert is here, Dr.
Yeah.
Subrakanta Pandit. Subrakant sir? Yeah. Sarada sir, Sarada Prasan Patti.
Good afternoon, Professor. Good afternoon, Professor Panda.
Good afternoon. Good afternoon. So, ma'am, I'm still a scholar, research scholar. I'm still in that mode. Yet to become a professor.
That feeling you'll get till also when you'll be a professor, that time also the same feeling.
Once Durga sir told me, Subrakant, you are no more a student. Behave like a professor.
good afternoon all. Good afternoon all present here. On behalf
Good
of SOA
afternoon, ma'am.
University, I welcome our speaker, Dr. Subhakanta Panda.
Hello, all of you. Good afternoon to all.
Let me introduce Subhakanta Panda. Dr. Subhakanta Panda is currently working as an assistant professor in the Department of Computer Science and Information System at BITS Pilani, Hyderabad campus. He has done his PhD from NIT Rourkela. His research area is software testing, and he has more than 30 plus published articles, papers, and book chapters in various journals, conference, and edited book volumes. Currently, he has adapted the Indian edition of the book Data Structure and Algorithm in Python by Goodreads, which is recently available in Amazon. He has delivered talks in reputed organizations and institutes like DRDO, NIT Rourkela, and others. Now, I request our speaker, Dr. Suprasanta Panda, to deliver his talk.
Yeah,
Suprasanta,
thank you, ma'am. Thank you so much for having me and giving me an opportunity to speak to the students. So, good afternoon to all. I'm already been introduced. So, nothing more to add to that. All I would say that the book I adapted that ma'am was mentioning is a very good book. So, please do follow that book. So, hope my slide is visible to all.
yes, it's visible.
Yeah, so I'll start with this talk on blockchain and its application in healthcare. Though it has got wide applications in many domains, but we'll first get introduced to the blockchain basics and then we'll see how it can be adapted to the healthcare domain and what kind of problems it can solve in healthcare domain. And before I proceed, the assumption is that the audience is not very much acquainted with this domain called blockchain. Probably you would have heard about it. And the assumption is that you are a little bit familiar with data structures like linked list. So, which I'm sure anyone at a basic level course would have done in the initial years of engineering. So, with that assumption, we will start our discussion. Now, this is how the flow of discussion would be for today's talk on this topic. Now, blockchain at a very basic level, it's a continuously growing list of records called nodes or blocks, and they are linked and secured by the cryptography. And this is why I said that understanding of linked list is required. It's pretty much similar to that of a linked list. In a very native and basic form, if you secure your linked list by applying some cryptographic algorithms, then you can call it a blockchain. The only difference being is that linked lists are not distributed, whereas blockchains are distributed. When I say distributed means they are spread across geographic locations. So in my system, I may be running a blockchain and the same thread would be running in somewhere in Bhubaneswar, somewhere in Bangalore, somewhere in US. It could be across the globe. Okay, so that's what is the blockchain, or that's what we mean by distributed nodes. Before I go further, so I want to tell you a story, like a case study. And then at the end of our talk, I would expect another case study from you. I mean, that would ensure me that what I delivered is well taken. So this story goes like this: like in your university, in your department, um, your professors are teaching you different courses. They are conducting exams, different kind of evaluations. There would be a mid-semester exam, some assignments, some quiz tests, some projects, some end semester exams. So what they do, they evaluate you and assign you some scores, some marks, some grades, and keep a record of that. So at the end of the semester, they may be assimilating all those marks, totaling it, and then sending the marks to some division, like some academic division, some clerical staff would be taking care of that. And then it will be going through the examination division sections, and finally you would be getting your results. Okay. Now this story here is that now Professor X gives the marks on different individual components, which probably would be at some point of time be handled by a clerical staff. Now there are good chances, likelihood that the mark would get manipulated. Okay, maybe some because of some different reasons. I don't want to highlight those reasons, but the point here is that if they are getting manipulated, the professor would not get to know that the marks has been manipulated. And our life is so hectic that we hardly bother to see for each and individual that the marks that we sent is actually reflected on the report card, or the result is reflecting those marks. So what do we do? How do we address this problem? Okay. And the problem, the solution to the problem is that at each point of time, if we if anyone tries to tamper or manipulate those marks, then it would should get conveyed to all the stakeholders, like including the professor, the head of the department, or the academic in charge, whoever is the person involved, the examination in charge, whoever. So they should get informed that something has happened to the original content. Now, typically in today's context, we all are operating on the basis of trust. Okay. So we trust the people who are taking forward this process from us, like from the professor. So, how do we not depend on mutual trust, but to come up with a authenticate system that will take care of it? Okay. The answer to this is blockchain. And during this course of my talk, I want you to relate like how blockchain can be useful to the scenario that I just described. And then at the end of the talk, I'll be happy if some of you can come up um, with another case study, another story where you feel or you think that blockchain can be applied. Okay. And don't worry, I'll give you enough um, uh, thoughts and ideas so that you can relate and come up with some answer. But please don't Google and tell me, because if you Google and find out some case study, then I would get to know because I have Googled all. So think, just you'll get lot of case studies like that. So now before again going to further details on what blockchain is and how it works and all that, let's see how typically so as shown here in this figure, blockchain typically looks like this. So there are a series of blocks which are interconnected. Okay. Now this interconnection is taken care of by cryptographic algorithms. Okay. Now how does that happen? That is where each block is identified as we have a unique fingerprint. So each block has a unique identification number. Okay, that we called a hash code. and this hash code is there for each of these blocks, and each block would contain its own hash code of the next block. That's how the linking happens, and also the hash code of the previous block. Okay. So typically you can imagine in the context of a double linked list. Now linked list, when I say they contain some information, like what information it will contain? It will contain the transactions. Okay. What does a transaction mean? It may be a simple payment. Suppose some student is going to deposit a college fee or hostel fee. So that's a transaction. So you get a transaction ID, you store it here. So there is no limit. As many transactions you want to store, you can store it here in a block of node. Okay. A transaction did not be essentially payment basis, like digital payment transactions. It could be also like a professor entering the marks. So a professor for some course has entered a mark, all the marks of the students. That's a transaction, right? And the professor is handling 2 to 3 courses. So for three different courses, there will be set of students for which individual marks are to be uploaded. So there are 3 transactions there. So this is how typically a blockchain would look like. Okay. Yeah, one more point I forgot to add is that whenever you have any queries, please stop me and ask me, because I'm in presentation mode. I would not be getting your questions. Okay. And I'll not advise to keep your questions towards the end. So better to get clarified as and when the doubts come. Now this is another view of that same thing which I have described just now, that each of these blocks are representing the hash code and the data. Now here you see something called a genesis block. Genesis block is the starting point of the blockchain. So as we in the linked list, we have a header node. So in the blockchain context, you can imagine this genesis block as the header node. Okay. So previous data you see here 000. That means there is no previous node to this. The chain starts from here. Okay. And also it need not be necessarily sequential. There can be bifurcations. From here the another chain can start. Okay. So all those complexities we'll avoid for the time being. um, for the time being we'll keep it simple. Okay. So previous data, which is again in hash form, and the identification again in hash form, and it keeps the data, previous data and the next data, all in hash forms. And that's why we say that they are cryptographically linked. So this gives a little elaborate view of what we have seen in the previous 2 slides, like the content and how they are interconnected, the transactions. And typically, if you break this down and change the structure, it would typically look like a tree structure as this one. So each transactions associated with a hash value, that is the node, and those nodes are keeping track of the other nodes. Now, there are some key characteristics for any blockchain network. No matter what case study you apply to this blockchain. So, normally this blockchain, if you have heard, so sorry, we are having a lot of birds. So, yeah, if any scenario you apply this blockchain to, not necessarily cryptocurrency or whatever fancy terms you might have heard. So we can apply it to any scenario provided this key characteristics satisfy. So when I said that mark entry scheme, we can apply blockchain, that means this characteristic should satisfy there. Now, if you come up with how to know that at blockchain can be applied, is worth applying blockchain to a particular scenario or not. So I'll give you some idea on that. But if you apply, then that should apply, satisfy this four characteristics. First one is consensus. Consensus means, so for a transaction or a new node to be added to the chain, so the other stakeholders who those are there already present, so they should have a validity. They should give their consensus that okay, this is valid to be added. Okay, this is correct. So when a professor is entering the marks, so there must be people to validate that okay, the mark entry is correct. Now from the professor, the mark goes to someone else. From there, before it goes further, it needs to be validated again that this what is was sent is getting forwarded. It's not tampered. Okay. So a consensus mechanism has to be there. That's a must. Next, provenance. Okay. So provenance means you can trace back the origin. Okay. Like where it has originated. So at any point of time in the chain, be suppose the professor in charge or director or whoever wants to check like these marks are originated from where, has come from where, that has to be there. So that's why the link to the next and the previous. Okay. So provenance needs to be satisfied. Then immutability means that no one in between should be able to or allowed to tamper the content. Okay. Now if for some reason, because we have so much of talent, like as our prime minister says, कितने तेजस्वी लोग हैं हमारे देश में. So we don't have, we have huge talent. Okay. And that talent can be used for a negative activity like this, like to tamper with the blockchain. Okay. And supposing it happens, the content is tampered. Okay. So anyone trying to attempt to tamper the content should not be allowed. Okay. And that's the typical characteristics of a blockchain implementation. I'll show you. Sorry, I will tell you how that is satisfied. But immutability means, sorry, yeah. So immutability means that it is tamper proof. No modifications can happen. Okay. Now suppose it may so happen that during some mark entry something, some mistake unintendedly happens. Okay. In that case, so another new transaction is created and entered. Okay. Without deleting that previous one. Okay. That went wrong. Then how do we differentiate it? Which one is correct, which one is wrong? Because every transaction that I said is has having its unique ID, has a timestamp associated with it. So from that we can get to know. Okay. But we don't allow any, once a transaction is been confirmed, like consensus has been received, then and it is entered, then we don't allow any modification to that. Okay. So we may enter a new one, but we can't modify that. Then is the finality. Okay. Finality means the ownership, who owns that, and where it is stored. Okay. And what are the details, all those, that is validation of the completion of the transaction, that is ensured. Okay. So any blockchain in any case scenario or case study should satisfy these four characteristics. This is must. So and another thing that means about this finality is that uh, every stakeholder will have the full copy. Okay. Again, I have a good visualization to show you on that, what I mean by that. But every stakeholder will have the full copy of all the nodes. So this is again another scenario where a vehicle registration happens. Okay. So what are the things involved in a vehicle? Supposing you want to buy a car or a bike. Okay. So it goes through different processes, which probably we are not knowing many things. What we know is that we are just going to the dealer, buying a bike or a car, and going to the registration office and getting it registered. Okay. But what happens after that? If you have sold it to some other person. Okay. So again, that fellow has to go to the registration office and get it done. Okay. And how does the dealer would know that to how many other persons this bike has been sold to after the dealer has sold the bike to the first customer? The dealer want to know. Okay, but in many scenarios we need to know the full track of the whole life cycle, starting from the manufacturer to the different buyers of that bike or a car. Okay, so without a blockchain, the typical scenario is like this, as shown here, that the manufacturer maintains its own ledger. Ledger means record, and the dealer would maintain its own ledger. Similarly, the leasing company, the lessee, the scrap merchant, all. And on top of that, the regulator. Now, regulator has to keep track of all these ledgers. Okay, at different point of time it has to, like supposing an accident has happened, okay, and the owner is not identifiable, then from some this engine number, chassis number, they need to go and track, find out. So that's a very hectic and long process. So now how blockchain can be applied to this scenario? Now this is a typical scenario where blockchain is applied. Okay, so what we are doing, that this whole transaction and the ledger is maintained, which is of course guided by some smart contracts. I'll come to that. What does a smart contract would mean? Okay. So, but it's a like a shared asset. Okay. That ledger is not individually maintained. So it is shared across. So they, what they do, they maintain a node, they create a node whenever a transaction happens, and that node gets shared across all the stakeholders. Okay. So at any point of time, the whole life's process of that bike or a car is known to each and every stakeholder involved in this. So this we call a network. Okay. And in this network, all are connected to each other. Again, I'll come to this network. I'll show you a visualization to understand better. For the time being, they are all in a network connected. Otherwise, if you are not in a network connected, then you won't be having a share resource that can be shared across. Okay, for that. So I'm sure you can clearly now distinguish the difference between these two scenarios. Okay, where there are different interpretations, different records are stored at different places, they are maintained. Okay, and the different copies would have to be maintained. Some would get lost somewhere, some would get misinterpreted. A lot of discrepancies can happen in this scenario, and on top of that, the hecticness involved in identifying a particular resource or a transaction. Here nothing of that sort can happen. Okay, so this is how a blockchain typically. So now some changes to be done by whom, say, dealer. Suppose dealer is doing some changes, so this change will be communicated across all. Okay, now before the dealer can add a node or a transaction, new transaction, it has to be validated. Okay, that's we call consensus. Okay, that consensus mechanism will work here, and it will be validated by everyone else here, and then it will be added. So everyone is aware of what's happening. Okay, so that same copy is maintained across everywhere. So discrepancies or tampering chances are less. So now I was talking about trust, like we are functioning on the basis of mutual trust. What if the trust is broken? High chances. Okay, so but when we are implementing a trust through blockchain, then how it works? Okay, so these are the 5 attributes that I want to tell you that builds trust, or the trust can be built through blockchain, or blockchain takes care of that. So these are called distributed and sustainable is the first point. So what it means is that though it is distributable, that is distributed across different geographic locations, okay, and but it is sustainable. Okay, it sustains, it is this because the same copy is shared across all the stakeholders, so there is no ambiguity there. um, so that's why the trust is there. Okay, when you are sure that when the professor is sure that the marks he or she had entered is the actual mark that goes and finally gets reflected on the report card, then there is trust. Okay, the system is trustworthy. So next, blockchains are secure, private, and indelible. Okay, secure means, as you know that, as I said, that one cannot tamper. If one wants to tamper, then it gets detected. Why or how it will get detected, I'll come to that point a little later. Then it is private because you have the only access. So here, to this node where the transactions are maintained by the dealer or the leasing company, they have the exclusive access to this node only. No other person can access this node. Okay, it is that secure in blockchain, of course, because of cryptographic techniques. Okay, so but that privacy, that confidentiality is maintained. Okay, but as you can see here, it says that permissions and cryptography prevent unauthorized access to the network. Okay, so confidentiality is maintained through cryptography is understandable, but how to prevent unauthorized access? What does that mean? Means that the people who are only authorized to access something will be accessing that. So that means it's a typically identification problem. Okay, you need to identify that the user is the actual user to be accessing this system. How do you identify that? And again a research topic in itself. Okay, so typically we cover this and discuss this under identification and authorization management, IAM. Okay, so that's how we are evolving. Like earlier days we used to have simple login ID, but then it was realized that simple login ID would not work. Then we had OTP mechanisms. Then we had other mechanisms like facial recognitions and so many others. Okay, but each mechanism that we employ, okay, and now we are into two-factor authorization or identification, three-factor authorization, four-factor, n-factor, multi-factor authentication. Now they have their own pros and cons of implementing. Like if I implement a facial recognition system in addition to the login and password, well, that can be done, but it may not work in all scenarios, right? So in many scenarios where this identification and authorization is to be done, but there would not be a good mechanism for camera to work, for camera, visual recognition. Somewhere it would be ideal to use your fingerprint, somewhere it may not be. So each of these solutions would have their own pros and cons. So that's a different domain. Maybe we can discuss it in some another talk. But for the time being, yes, well, let's assume that uh, blockchain is both secure, private, and indelible. So next, it is transparent and auditable. Transparent, as I already clearly said, that the whole transaction copies are there with each and every stakeholder. So there is cannot be any anyone cannot mess around with that. Okay, it's not that I have a different copy and someone else has another copy. And it's auditable because you can always trace back to its origin and who did what. Then it is consensus based and transactional. Consensus, I have already said that it's a validating algorithm. Okay, so again I'll specifically discuss on consensus, but for the time being it's some mechanism by which you allow people to validate. Okay, now when I am saying that this transaction is valid, that means I should have some say level of confidence or some rules and regulations on basis of which I am saying that this transaction is valid. So that is consensus algorithm, which needs to be developed, of course. So then it is orchestrated and flexible. Orchestrated means you can always arrange, build from the way you want to. Like you can always design this consensus algorithm the way you want to. You can always, I'll give a analogy on that. I have a beautiful analogy to tell. So that will even further clarify what I'm trying to say. Now it's flexible because you can always add and remove people from the chain. Okay. So that's how these 5 factors they contribute to this trust. Okay, and that's why more and more um organizations are now getting into blockchain applications. Now, I said that how do you know that a case study would fit into the blockchain, or rather, in the other way, like we can apply blockchain to a particular scenario? Yes or no? Is it always about security, or it is not? Okay, so these are the questionnaires that needs to be answered. Like, does my business network need to manage contractual relationship? Okay, so wherever there is a contract, like for example, you are taking a subscription, like say Netflix, Amazon Prime, or whatever, or any video transmission subscription you are taking. Now, what if you have paid for 1 year subscription and you realize that more than, I mean, anytime you log in, this streaming is not happening, it's always buffering, then the quality is not good, okay, or it's not available, you are not even able to play a video. So then what happens? You feel like being cheated, right? So there is a contract between subscriptions. So when you are subscribing something, there is a contract that gets built up, okay. um, that in a typical cloud scenario we call it a service level agreement, and here we call it a smart contract. Okay, so that would specify like on what conditions what will happen, like if the service is not 90% available to the consumer, then what is the penalty applied on the service provider. Okay, or something happens like that. So these are all contractual things. So wherever any scenario where a contract thing comes into picture, an agreement thing comes into picture, there you can apply blockchain. So do we need to track transactions that involve more than two parties? So any activity that involves more than two people or two organizations, two institutions, there blockchain can be applied. So is the current system complex or costly? Okay. So there are systems you might be hearing about many online examinations happening by different organizations and institutes. Okay. So like for example, BITS is conducting its entrance examination. So it's not everything is taken care of by BITS. Okay, so there are many parties involved, the one who would facilitate the conduct of the exams, the one who would locate the centers for us, one who would look for the facilities available or not. So many people, so many organizations are involved. So in such scenarios, a very complex system. So um, there we can think of applying blockchain. Then can the network benefit from the increased trust? Okay, or is the system prone to errors, or is the current transaction system vulnerable to fraud and cyber attack, human error? Okay, so all these if questions, any of these questions you are answering a yes, that means you can apply a blockchain there. Okay, so this is a very beautiful slide that you should appreciate, that you just can't blindly apply blockchain because everyone is running after blockchain, so I will apply. No, it's not like that. So some important terminology is always associated with the